This is an explanation for problem 2 from modeling in the time domain B. And yeah, the answer is given, but I wanted to go over a solution. So we've got this 2-degree freedom torsional system. If you were to hold this shaft fixed, or this end of the spring, then this end of the spring could still move. If you hold this end of the spring, then this end can still move. We can only reflect through gear pairs on whenever it's just 1 degree of freedom. So we can reflect this impedance through the gear pair here, and that's what we'll do. The displacement and the torque are not reflected. They're multiplied by a factor of the gear ratio, but not by that squared like an impedance would be. So I'll show what that looks like. And also the displacements, this one's labeled theta 1, we'll call this one theta 2, and note that it's positive left. Well, if this is positive right, then theta 2 is positive left, meaning a positive displacement of theta 1 is in the right direction. That corresponds to 1 in the left direction of theta 2 because the gear pair is going to reverse the direction. And then the torque here, this torque gets multiplied by N2 over N1 at this shaft. So let's see what that looks like. Okay, here is the original system, theta 1 and theta 2 and the torque. And this is N1 and N2. And here's the equivalent system where we reflect the impedance through here, or through the gear pair down here, and then the torque. And again, the directions are reversed. So we've got, we'll call this theta 1b. I think in the answer on the slide it's called theta 2, but I dislike that. So we've got theta 1b and theta 2 here. In the answer on the slide it's theta 2 and theta 3, but I think that's a little confusing. So theta 1b is equal to N1 over N2 times theta 1. And then the torque applied is multiplied by N2 over N1. So the torque kind of gets magnified here, well, assuming N1 is smaller than N2, and then the displacement gets reduced. Theta 1b is smaller than theta 1. And then now we just need this mass moment of inertia. And the original value is 50, and the gears are 30 and 100. So this mass moment of inertia is 50 times 100 over 30 squared. All right. So we can draw a free body diagram for each of the degrees of freedom, and we have 50 times 100 over 9. There's our external torque, tau times 10 over 3. And then the spring is going to try to, well, so remember this is the direction of theta 1b. So the spring is going to try to oppose that. And so that torque is 100 times theta 1b. But then if we hold this still and move this, then that's the spring is going to try to pull theta 1b along with that. So there's 100 times theta 2. Let me get a pen that's writing better. And then likewise we can do a free body diagram for the second mass moment of inertia. And here's the direction, theta 2, and the magnitude, the impedance is 100. So we've got here 100 from the damper times theta 2 dot. It's going to try to oppose that. The spring is also going to try to oppose that. So that's 100 times theta 2. And then if we hold theta 2 still and move theta 1, or theta 1b I should say, theta 1b, that spring will try to pull it along. So now we can write force balance, or Newton's second law, to get our differential equations. And so from the first one we get, and we're saying left is positive now, so 10 third times tau minus 100 theta 1b plus 100 theta 2 is equal to 5,000 over 9 times theta 1b double dot. And then for the other mass moment inertia, we have 100 theta 1b minus 100 theta 2 minus 100 theta 2 dot is equal to 100 theta 2 double dot. Okay. Now we can choose our state variables. So we'll say x bar is equal to theta 1, omega 1, theta 1b, omega 1b, theta 2, and omega 2. Because these variables have their derivatives in these equations. And now we just need to put this into matrix form. Oh, also, we can write the output equation. Y, it's the torque. Wait, what is the output again? The output is theta 1. So y is just, oh yeah, we need to use this expression. So let me back up a little bit. Theta 1 is equal to n2 over n1 times theta 1b. So our output equation, y equals 10 thirds 0, 0, 0 times x bar. Okay. And then, so I'll leave it as an exercise for you to go from, oops, I didn't mean to put that in matrix form. So this is 10 thirds times theta 1b. That says y. And you can put the state equations into matrix form on your own and then check that against the posted answers.